For this Pencast, we'll be looking at Pascal's triangle and its role in binomial expansions. So to get started, let's first of all remind ourselves what a binomial expansion is. Well, a binomial in its most basic form is a plus b, and a binomial expansion is a plus b raised to some whole number power up here. So for obvious examples, we would have a plus b to the second, perhaps a plus b to the third, and then the very, very basic ones, a plus b to the first, and a plus b to the 0th. All are examples of binomial expansions. Most of these, a plus b quantity squared, a plus b quantity to the third, a plus b to the first, of course, and a plus b to the 0th, are all easy to simplify algebraically. Expand really means to multiply them out. So if we look at these in order, we would have a plus b to the 0th equals just 1, a plus b to the first equals a plus b to the second equals a squared plus 2ab plus b squared. Now we don't have much experience so far with a plus b to the third, but let me just tell you that that multiplies out to a cubed, plus 3a squared b plus 3ab, b squared plus b to the third. Now, while you're watching this Pencast, you want to keep your eye on the coefficients because that's the main focus and certainly the main area that Pascal's triangle as a tool helps with. So if we look here at a plus b to the first, I'm going to put in the coefficients 1 and 1. And right below that, looking at a plus b quantity squared, I'm going to put in the coefficients for the lead and trailing terms. So when you look at just the coefficients, you have 1 and then 2 and then 1. And then looking at the last one, I'll put in the 1 here and the 1 here. So let's take a look at these coefficients that I'm highlighting in green. Pull them off and create a triangle with the coefficients. That triangle is called Pascal's triangle, and we'll look at it far beyond expansion to the third power on the next slide. So taking the coefficients from the last slide, we had 1, and then 1 and 1, 1, 2, 1, 1, 3, 3, 1. Now remember that this dealt with an expansion power 0, meaning it was a plus b to the 0th. It was the 0th power of a plus b. That was the first power, that was the second power, that was the third power. So while I'm expanding this triangle, start looking for patterns that I can assure you they are not coincidental. Any pattern you see would be helpful. So I'm going to put in a couple more rows and let you see how it plays out. 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. And you might have already noticed that the two numbers up and to the left and up and to the right from any row sum to give you the number directly below it. So 4 plus 6 equals 10, and you can see that over here, that 2 plus 1 equals 3. So looking at that pattern, you should be able to give me the next two rows. Should I pause for dramatic effect? Okay, that's long enough. 1, 6, 15, 20, 15, 6, 1. And the last one we'll look at, because once you get the idea of what's happening, you can create Pascal's triangle as far as you'd like. Although most that I've seen online or that I've created myself go up to an expansion power of 15, and after that it gets too unwieldy, the numbers get too big to fit in a triangular form, and then it's messy, and you move to what's called the binomial theorem, which we'll discuss in Algebra 2. So that last row is 1, 7, 21, 35, 35, 21, 7, and 1. Additionally, for you English nerds, the rows are a palindrome, which means they read the same this way as they do that way. So a couple of patterns to keep in mind, and you can create your own triangle anytime you want. Once you sort of memorize these first three lines and then know the pattern of how the rest of the triangle is created, then you're like, okay, I got it. So I'm going to take this row of coefficients right here onto the next slide and show you how they play in to binomial expansions. We will be looking at a plus b quantity to the fourth. The second number in any Pascal row gives you the expansion power. That 4 is this 4, called the expansion power. All right, so we'll look at how Pascal's triangle comes into play with a plus b to the fourth. Okay, so our coefficients from last slide were 1, 4, 6, 4, 1, and we're going to use them to expand out a plus b quantity to the fourth. And granted, you could take this a plus b quantity to the fourth and line them up and just throw algebra at it until it dies and get the same answer. But I don't know, maybe past 4 or 5 and you'd be hating life. So keeping in mind these Pascal coefficients and a plus b to the fourth, that will equal, and we will simply create what all of this work up here would result in after you multiplied it all out and combined like terms and put it in order. You can only imagine how much work that would take. We can simply assemble our answer. So, taking the coefficients, I'm going to go 1 AB plus 4 AB plus 6 AB plus 4 AB plus 1 AB. Now I'm going to look at the exponents. The exponents of A start with the expansion power 4 and descend in order 3, 2, 1, 0. The coefficients of B start at 0 and ascend all the way up to the expansion power, 3 and 4. And as you're looking at this more closely, you'll notice that every monomial, this is a degree 4 monomial. Of course, it simplifies out to just a to the fourth, so univariate monomial, is just the exponent that you see. Recall bivariate or multivariate monomials, the degree is the sum of all the exponents. Well, that is a degree 4, degree 4, degree 4, degree 4. So you can't mess this up. There are self-checks all along. The final step in this basic example is to simplify it. I'm going to remove the coefficients of 1, and I'm going to remove the b to the 0th on the lead term and the a to the 0th on the trailing term, keeping the rest of the order and everything else as written. So this is a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab to the 3rd plus b to the 4th. Done. Done. If you would like to check that, if you were to FOIL out these two up here, FOIL out those two, and compound distribute them together to get this, feel free. But trust me, that's the right answer. All right, let's take the coefficients for expansion power 5, and that would be 1, 5, 10, 10, 5, 1. You may have already noticed that the quantity of coefficients is always 1 more than the expansion powers. So we're looking at an expansion power of 5, the second number of the Pascal coefficient row, and notice that we have 6 coefficients. So again, another self-check in order. However, the binomial that we're going to expand with this one will be a minus b to the 5th. And the first order of business with this one is to change it to a sum. So a plus negative b to the 5th. And you might ask what that's for, but I'm going to go ahead and proceed with this and watch what I do with the negative b. So again, I'm going to go 1 ab plus 5ab plus 10ab plus 10ab plus 5ab plus 1 AB. I'm going to take my A exponents starting at 5 and descend in order. And then I'll take my B exponents starting at 0 and ascend in order. And then as we looked at in the previous slide, let's double check our degrees. 5, 5, 5, 5, 5, 5. Life is good. All right, well, you might have already seen that what I have written so far is the expansion of A plus B to the fifth. So you know we can't be done yet. So we're going to do what is in essence a substitution. And I'm going to put in little parentheses right here on the B. Now I'm putting it in grouping just the B and leaving the exponent on the outside. What that is for is I'm going to now take this negative B and put it inside each little parentheses. Now obviously you're not going to do it this way when you're doing a problem for yourself or on a test. That's far too convoluted. This is for explanatory purposes. So what I do is physically or mentally is I consider really A plus B to the fifth or X plus Y to the fifth, whatever two variables you want to use. And then, see, I start with this, and then I do that original expansion that I have written in blue. Then I go over to my actual binomial and look and see if there's anything to substitute in for A and substitute in for B. So as we look at that, remember that if I have negative B to the nth power, that equals negative B to the n when n is odd, and negative B to the nth power equals B to the nth if n is even. Now that little rule deserves to be a brain tattoo. I wish I had written it a little neater, but we will do it here and call it a brain tattoo. All right, keeping that in mind, we're going to look at this messy expansion with the blue, the colored exponents, and the purple substitution and simplify it out. So the first term here is A to the fifth. That should be no problem. Then I'm going to get minus 5A to the fourth B plus 10A to the third B squared minus 10A squared B to the third plus 5AB to the fourth minus B to the fifth. And you might be asking yourself, what happened to the negative B? Well, the negative B affected the operator. So the terms themselves don't look like they have a negative in place. But remember, when you're expanding A plus B to whatever, everything is plus. Well, when you have the negative B, on alternating terms, it affects the operator. And that's it. You can circle this one, sort of. There we go. Happy face and call it done. Now we'll look at an example that deals with a substitution, but it's not a substitution due to a minus inside the binomial. And let's take an easy expansion. We'll do 1, 4, 6, 4, 1. So that's an expansion power of 4. And we will look at a binomial 2x plus y. I'm just going to switch to x and y. They don't behave any differently than a and b. So watch how this one plays out. So if I had a plus b to the fourth, comma, the expansion would look like 1ab, we know how this works, 4ab plus 6ab plus 4ab plus 1ab. Take your a exponents, start at 4 and descend in order, 0. And then take your b's, start at 0 and ascend in order, 3, 4. Double check your degrees on everything, 4th degree, 4th degree, 4th degree, 4th degree, 4th degree. Life is good. I wonder if I should pause for dramatic effect. Do you know what I'm going to do next? Okay, that's long enough. It should be clear that I'm going to now take 2x in its entirety and substitute it in every time I see an a. Now watch me group the a, keeping the exponent on the outside because the exponent applies to a in its entirety, and a is no longer a, it's 2x. Now, plugging in the y or substituting the y in for b simply results in a variable change, so I'm not going to do much to that. So I'm going to have quantity 2x to the fourth. And while I'm doing this, I'm going to drop the 1 and the 1 coefficient and the 0th degree terms, just in the interest of clarity, plus 4. Now I'm putting that there. That's my Pascal triangle coefficient. That doesn't change. A now is 2x to the third, and b is now y, plus 6, Pascal coefficient, nothing changes, nothing happens to it. A is now 2x, and now I have y squared plus 4, that's my Pascal coefficient, 2x to the first, y, plus, I don't need the 1, I don't need the 0th degree monomial, and b is now y to the fourth. So now look at that, keeping in mind that you have to apply the exponent to each factor of a product. When you're done with that, then you multiply that by the Pascal triangle coefficient. So 2x to the fourth, that would be 16x to the fourth. Do you know why? Good. Plus, and I'm just going to say this, watch what I'm doing. 2 to the third is 8. 8 times 4 is 32. 32, x to the third, y, plus, now watch, I'm up here at this term. 2 to the second is 4. 4 times 6 is 24. I'm simply following order of operations. Plus, now I'm here. 2 to the first is 2. 2 times 4 is 8. So I have 8x, and I don't need x to the first. Y, oops, I forgot my cubed on that one. Y to the third. As I'm doing that, I see I forgot that. Let me double check that. Life is good. Plus y to the fourth. Got it? Boom, boom, boom. And a happy face. So what we look for here is that perhaps you look at a plus b to the nth as a formula, and then substitute in whatever a equals in your given binomial. So if we had 2x plus y to the fourth, and you compare it to this, we would say, okay, a equals 2x, and I think it's a really good idea to like parenthesize it and call it quantity 2x, so that you realize that the exponent that would be on a applies to the 2 and the x. And then you might go ahead and say b equals y. Parentheses are optional on that one. And just to be complete, you can say, hey, n equals 4. So it gives you all the information you need. The n equals 4 right here tells me, okay, I'm using the 1, 4, 6, 4, 1 row of Pascal's triangle. This tells me to substitute in quantity 2x wherever I would see a in my sort of basic or formulaic expansion. And then b equaling y, let's face it, it's just a variable change. All right, let's try another one. Okay, for this one, we're going to use very basic Pascal expansion, 1, 3, 3, 1. Expansion power of only 3 because it's complicated enough. The binomial that we're going to expand would be 3x minus 2y to the third. So you want to keep your eye on all the things that are different compared to a plus b to the third. A plus b to the third is nice and straightforward. Let's look at what's different. Well, a now is equal to quantity 3x. B now is equal to quantity negative 2y. N is, of course, 3, but that's obvious. Now, you might be wondering why b is negative 2y instead of 2y. Well, mentally, I made a switch here, and I'm considering this addition, 3x plus negative 2y, all raised to the third power. And you don't have to write that physically, but I would keep that in your mind, that you're making it plus, and then you're doing a substitution after you have your basic a plus b to the third expanded out. So a plus b is 1ab plus 3ab plus 3ab plus 1ab, powers 3, 2, 1, 0, powers 0, 1, 2, 3, double check degree, 3, 3, 3, 3. Now let's do our substitutions. So I'm going to drop the 1s and the 0th degree monomials. So my first term would be normally a to the third. It's now 3x quantity to the third. Plus, listen up, Pascal coefficient, the a substitution, which is now 3x raised to the second. Now my b substitution, minus 2y, and I'm not going to put to the first in, plus Pascal coefficient 3, a substitution 2x. Oh, sorry, I wrote 2x, I meant 3x. 3x. B substitution, negative 2y to the second, plus, I'm going to drop the 1 and the a to the 0th, leaving me the b substitution, negative 2y to the third. So let me write a little bit right here. So 1, Pascal coefficient a, and I'm going to put that in quotation marks. It's just like what a is, if it's just a or x or whatever, or the expression, if it's 3x, 5x, 2x, something like that. And then this becomes whatever b is. That way you can set up your expansions always using plus. You don't have to worry about the alternating signs until you substitute in a or b and just let the math take care of itself. So looking at the first term, 3x quantity to the third, tell me you know that equals 27x to the third plus, oops, I wrote plus by force of habit, and I know that's not going to happen. So 3 to the second, and I'm going to pause and I'm going to highlight. I'm right here. 3 to the second is 9. 9 times 3 is 27. That's why that term is going to come out the same. However, I'm still not done. 27, now I'm going to bounce way back here to the negative 2, and that gives me minus 54 x squared y. Let me just double check that. 3 to the second is 9. 9 times 3 is 27. 27 times 2 is 54, and I have a minus. Life is good. All right, plus, and you might be able to tell that these coefficients get really big really fast. So let's look over here at the next term. I have Pascal coefficient right there, 3. So that's going to give me 4. 4 times 3 is 12. 12 times 3 is 36. There is no indications that I'm going to get a minus because there's my minus and the corresponding power is even. So where was I now? 3 times 3 is 9. And 9 times 4 is 36, so I have 36xy squared. And my last one is going to be minus 8y to the third. Let me just double check all that before we circle it and give it its own happy face. All right, back to the first term. 3 to the third, 27x to the third, got it. 3 squared is 9, 27, 54, got it. 2, negative 2, excuse me, to the second is 4. 4 times 3 is 12. 12 is 36. There's my x. There's my y squared. 8y cubed. Double check your powers on all the monomials, excuse me. And I think we're ready for a happy face. Got it. All right, not another example. There'll be plenty of time to practice that. You can ask me questions in class, or I'll put them on the study sheet. Don't worry. But what are some takeaways from the Pencast? Well, what is a binomial expansion? So hopefully you know the answer to these, or you know where in this Pencast to find it. Pascal's triangle, what it is, how it works, and how to construct it to any degree that you need. And then expanding. And then under that takeaway, I might do the a plus b to the n model, and then the a substitution, and then the b substitution, if needed. And then don't forget to simplify. And that's a wrap. Tori out.